future of flight shouldn't be things with propellers and turbines, and should be more like what you see in Star Trek, with a kind of blue glow and something that silently glides through the air. When I got an appointment at university, I thought, well, now I've got the opportunity to explore this, and started looking for physics that enabled that to happen. The sort of mechanism that I found that works was ionizing air and then using electric fields to accelerate the air. What we achieved was the first ever sustained flight of an aeroplane that is propelled by electroaerodynamic propulsion, and that's also, by many definitions, the first ever solid state flight, meaning no moving parts. Well, the idea is kind of, it dates back until at least the 1920s, where a eccentric inventor at the time started experimenting with high voltage electrodes, and thought he had discovered anti-gravity, which of course was not the case, but that set some of the initial groundwork on mechanisms for creating what's called an ionic wind in the atmosphere, by having high voltage electrodes ionizing air and then accelerating the ionized air. So what we did for this design is to try and stick to something that looks somewhat like a conventional aircraft, but under the wing, rather than conventional engines, it has a series of electrodes, and those consist of an array of very thin wires at the front and then an array of aerofoils at the back. Now, those thin wires at the front are set at a very high voltage, plus 20,000 volts, and that constitutes the source of ions. This is ionized nitrogen from the atmosphere. Now, the aerofoils at the back, they're set at minus 20,000 volts, and so that creates an electric field, so the ions go from the positive to the negative, colliding all the way with neutral air molecules and creating this wind that goes behind the plane, and that's essentially how it flies. The flight was about 60 meters long, something like 10 seconds, so quite short. It was constrained by the size of the gym that we found to fly it in. Lacking infinite money and time and just wanting to do things as quickly as possible, that was what was on hand, and so we just asked the facilities manager if they would let us use the gym. They forced us to create a very long and detailed safety management plan, but then we were able to go ahead. Many attempts failed because of various things going wrong, like structural failures, the power electronics frying itself, so there were many first days, but the first day that it actually worked wasn't a sustained flight. It was about 50% power, so it was a power glide. Until that occurred, we still didn't know 100% whether this was really achievable, but after that point we knew that we were then within touching distance of successful flights, and the first sustained flights followed quite soon after, which were pretty exciting. It's probably the first solid state flight of a heavier than air vehicle, and I think that is has the potential to be a step that is very interesting. Of course, we don't yet know whether it will be practically useful and widely used, and obviously I hope it will be, and have an expectation there are a number of applications. There are definitely some limits. So one of the limits is the breakdown voltage of air, and that varies as a function of altitude. And we've worked out theoretically what the limits are to the thrust density, which is the amount of thrust force per unit area that's producible. Now, what that suggests is that in the nearer term, it will be easier to create smaller vehicles like drones, for example. I think the near-term advantage is probably in noise, especially if you think that perhaps in 10 years we might have urban areas that are filled with drones doing things like monitoring traffic, monitoring air pollution, or many other services we're yet to imagine. And drones today are quite noisy and irritating. Now, we wouldn't want our urban environments to be polluted by all this noise, so developing a way of propelling drones that's silent or near silent would be advantageous in that context. In many ways, it's much easier to make progress now than it was in the past. I mean, if you look at this wonderful aircraft behind us, which was the first ever transatlantic flight about 1919, I mean, people were risking their lives to make that kind of progress. Today, we're not risking our lives. We're able to test things using remote control without having to have pilots on board test vehicles. That means the vehicles can be much smaller, which enables us to build them and test them with less resources. In terms of how this fits in, I don't yet know whether you'll see large aircraft carrying people anytime soon, but obviously I'd be very excited if that was the case.